Today we're going to take the information that we've already learned and learn how to actually prove our triangles congruent by writing proofs. So here are some tips and a little sheet for you to use when you're practicing. Mark all the given information in the picture. Very helpful. List the given information in the proof. I always do that first. Look for the following relationships that I have listed on this page. Prove your triangles congruent. And remember, we have SSS, SAS, ASA, AAS, and HL. And we'll show you how to do this. Make sure to prove what you're being asked to prove. So just for today, you're proving triangles are congruent. You're not proving anything past that. But let's look at this little sheet just as a reminder. When you have a shared side, we talked about that last lesson. This right here is congruent to itself by the reflexive property. If you had shared angle, this one's kind of interesting. If I had a couple of overlapping triangles, this angle right here would be my shared angle, and it would be in both triangles. So we would say, for example, angle A is congruent to angle A, because angle A in the left triangle is congruent to angle A in the right triangle. Vertical angles. I talked about what I called the bow tie picture. Vertical angles are always congruent. When you have parallel lines, so if I told you these lines were parallel, you should be looking for corresponding angles, alternate interior, or alternate exterior. I will tell you 99% of the time it's alternate interior. Every once in a while it's corresponding. But most of the time you're going to look for that Z shape to find your alternate interior angles. And there they are. So that one's going to come up the most often. Perpendicular lines. If I tell you that AB is perpendicular to CD, it's very important that you follow the definition. The definition of perpendicular lines says two lines are perpendicular, they form right angles. So from this information, you could say that angle 1 and angle 2 are right angles. That's the definition of perpendicular lines. And you have to go in specific order. Now, once I have two right angles, I could do a couple of things. I could identify these two triangles as right triangles. If I was trying to do HL, I have to identify them as right triangles. Or I could take this from up here and say, well, if angle 1 and angle 2 are right angles because of the definition of perpendicular, angle 1 is congruent to angle 2 because of all right angles are congruent. And these are the reasons you would put in your reasons column, and these would be your statements. An angle bisector. Well, what's an angle bisector do? Well, if I told you that AB bisects angle A, we know what a bisector does. It cuts an angle into two congruent parts. So we would say that angle 1 is congruent to angle 2 because of the definition of a bisector. Segment bisector works the same way. We'll just take that same type of picture. If I said that AB bisects segment CD, when a segment is bisected, it gets cut into two congruent segments. So I would say that segment CB was congruent to segment BD, definition of a segment bisector. And on both of these, if you just say definition of bisector, that's acceptable. Midpoint. If I give you a triangle and tell you that X is the midpoint of YZ, then the definition of midpoint tells me that YX is congruent to XZ. Very much like a segment bisector, except they use the word midpoint, I use the definition of midpoint. They use the word bisect, I use the definition of a bisector. So this is kind of a, not really a cheat sheet, but a study sheet to use when you're looking at your pictures and you're thinking, I don't know what to do next. Think about these things. If you're finding these things, you can help prove your triangles are congruent. So let me do a couple of proofs with you as an example so you can see what you're supposed to do. So we'll take the first one. Given PQ is congruent to PS, we're just going to write down the given. Remember, this is your opening statement. You have to start with exactly what was given. Don't make any inferences from anything yet. You copy the given. And I'm going to label it PQ, PS, QR, SR. Now this is a pretty short proof, because notice I have this common side, PR, so I'm going to use my reflexive property whenever you see a shared side. And I think I have enough information. Let's look at our picture. We have, this is a side, this is a side, and this is a side. So I think my triangles are congruent. I needed three things congruent. So I'm going to say the prove QPR is congruent to triangle SPR by SSS. I'm going to go down to number 4 and do another one with you, and then you can practice. Angle 1 and angle 2 are right angles. AT is congruent to ET. So that's where we're starting. Angle 1 and angle 2 are right angles. Segment AT is congruent to segment ET. That's given. When I look at my picture, I see that I have a reflexive property here in the middle, so I'm going to do that one next. You don't have to do that one second. It could be third, but I'm just going to use it to get it out of the way, because that's an easy one I can grab, reflexive property. Now, I need to determine which rule I'm going to use, and that'll tell me which direction to go with my proof. So if you look at this picture, they told me these were right angles, and I have those pieces. I have two sides and an angle. Is it SAS? My two sides and my angle. Is this angle at the corner where the two sides meet? It is not. So this is not SAS. Normally we would have told you, oh, this isn't a rule because look, it's SSA. But we do have a rule that covers that as long as these are right angles. These are right triangles. That's a hypotenuse, and that's a leg. So I know I'm going to use HL. One of the requirements for HL was you have to have right triangles. So somewhere in my proof I have to actually say that triangle TAR and triangle TER are right triangles. And for that, that's the definition of a right triangle. If a triangle has one right angle, it's a right triangle. So we've done our things. Number 1, we said these are right triangles. Number 2, we have a hypotenuse. Number 3, we have a leg. So we have all of the pieces that we need in order to use HL. So I'm going to say that triangle ART is congruent to triangle ERT by HL. So whenever you are going to use HL, you have to say that these are right triangles. Okay, I might do one more with you. Let's do number 7. And then completing the rest of those is going to be your assignment. B is the midpoint of HI and TA. Maybe I'll just get this one started, because I think you can do this one. B is the midpoint of HI and TA. That's given. Remember, your given is exactly what was written. Don't do anything else with it yet. Now, since they use the word midpoint in the given, I'm probably going to use the definition of midpoint in my proof. So if B is the midpoint of HI, what does that tell me? Well, if B is in the middle, that tells me that HB is congruent to BI. I'm going to continue with this midpoint idea. If B is the midpoint of AT, what does that tell me? Well, that tells me that AB is congruent to BT. And the reason for both of those is the same, so I just went ahead and put them both in the same step. That's the definition of midpoint. Remember, if they use the term, we use the definition of midpoint. Alright, so I have two of my sides labeled. I just need one more thing, because every single one of our proofs had three things. Do you notice this is the bow tie picture? I have vertical angles. So I'm going to say angle 1 is congruent to angle 2 because vertical angles are congruent. It is not the definition of vertical angles. It's because vertical angles are congruent. It's actually a theorem. And that's my third piece of the puzzle. So if I label all of this and look at it, you should be able to see you have two sides and an angle that's in between them. The angle is where those two sides meet. So I'm going to say triangle HBA is congruent to triangle IBT by SAS. So go ahead and work on some more, check with your friends, ask questions, and prove the rest of these.